Assalamualaikum dan selamat sejahtera. So now I will continue my lecture for topic 2 part 3 on industrial distribution equipment. Okay, for part 3 only focusing on the example. Okay, now we go to in class practice number 1. Okay, the fault clearing time for a circuit breaker is to be assumed as 10 cycles on 400 volt 50 Hz system basis. The conductor type for the cable used is copper and the insulation type is SLPE. The final and initial temperature are given in table Q1. Okay, this is the information given. Okay, this is the types SLPE. And then this is the final temperature and this one is the initial temperature. Okay, question number 1 is point out the constant K for the cable. And number 2 is discover the minimum interrupting capability for circuit breaker if the total short circuit kVA is 30,000 kVA. Consider standard circuit breaker interrupting capacity as 55 kVA or 70 kVA. Okay, and then question number 3, analyze the minimum size in mm squared of the cable due to the short circuit temperature rise. Okay, next the temperature rise constant. Okay, K represent as K is a temperature rise constant. According to this standard, okay, the equation is K, okay, this equation, okay, this one is for copper conductor, okay, and this equation K is for aluminium conductor. Okay, the equation is almost the same, but the difference is the coefficient here. This one different with this one, and also this one. So the coefficient is different because the type of the conductor is different. Okay, this is the answer in class for practice 1. Okay, for question number 1, point out the constant K for cable A based on equation 1. Okay, this one for equation number 1 is from the previous slide that I have been explained. So we use this equation, okay, for copper type because the example is for copper type. Okay, and we have to put what is the value of final temperature and also the value of initial temperature based on the questions. Okay, after that we have to calculate what is the value of K, and we get the value is equal to 1, 4, 3. Okay, this is the value of K. Okay, questions number 2. Discover the minimum interrupting capability for circuit breaker if the total short circuit kVA is 30,000 kVA. Okay, this one is the value of S short circuit. Consider standard circuit breaker interrupting capacity as 45 kVA or 70 kVA. So first we have to find what is the value of I short circuit from the given S short circuit. So I short circuit is equal to S divided by square root 3 divided by V, which is equal to 43,301 M. So thus the standard rating for the circuit breaker A to be chosen is 45 kVA. 45 kA because this value is nearest to the calculated value. Okay, next we go to the answer for questions number 3. Analyze the minimum size in mm squared of cable A. Okay, to solve these questions, we have to use this equation. A is equal to minimum required cross-section area in mm squared. So we have already know what is the I short circuit from the questions number 2. and what is the K value from questions number 1. But we have to know what is the T. Okay, to get the T, we have to refer this table. Okay, this table is from the previous lecture, part 2. Okay, so we have to select number 1. Okay, this one is the pickup time, which is 20 millisecond. Okay, for these questions, the fault clearing time for circuit breaker is to be assumed as 10 cycle. So that's why for the fault clearing time, okay, this one, we have to times the value of 20 millisecond with 10 cycle. So which is equal to 0.2. Okay, so we put all the value in the formula, and then we get the value of 8, which is equal to 140.73 mm squared. Okay, next we go to in-class practice questions number 2. A 3-core aluminum butyl rubber power cables are laid from the switchgear feeder to serve 50 Hz 415 volt industrial load as given in table Q2. The cables are laid 90 cm underground in horizontal formation with 45 cm spacing to each other. The number of cables in the group is 2 nodes. The ground ambient temperature is 20 degrees Celsius and its thermal resistivity of soil is 200 degrees Celsius cm per watt. Okay, this is the table Q2. Okay, all the information in the table. Okay, the first one is the type of load, and then we have nominal rating, and also we have efficiency. Okay, and also we have utilization factor. Okay, this is the questions. There are 3 questions here. Number 1 is, if the fault clearing time for the network is 6 cycles with the short circuit capacity of 150 times the loading, identify the initial size of the cable based on the short circuit current withstand capacity criteria. And number 2, analyze again the cable size as identified in Q21 by considering the continuous current carrying capacity criteria by referring to appendix A. And number 3 is predict the voltage drop for both sides of cable found in Q21 and Q22. Okay, assume average power factor is 0.85 lagging and the cable length is 500 meter. The tabulated voltage drop is defined as below. This is the equation for voltage drop that we have to be used. Okay, this is the appendix A. Okay, this one is for current carrying capacity. Okay, this is the size. You can see here. Okay. Okay, this is appendix B. Okay, this one is for voltage drop. Okay, we can see here this is the size and this is the MVA value for different types of cable. Okay, this one for 3-phase and this one for single phase. Okay, this one single phase. Okay, this is the answer for questions number 1. Okay, firstly we have to add all the S load for all load given in the table. So to get the S load, so we have to use this equation, this formula. Okay, S divided by, this one is the efficiency, okay, times with the utilization factor. So we have to add all the S for all load. This one, okay, and then we get the total load here. This one load, this load is equal to 90.83 kVA. Okay, and then we have to find what is the S short circuit. Okay, S short circuit, okay, given in the questions is 100 times the loading. So we have to times all the S load with the 150 to get the S short circuit. Okay, so this is the value of S short circuit. Okay, then we have to calculate what is the I short circuit. Okay, I is equal to S short circuit divided by square root 3 divided by 415 volt. So we get the value of I short circuit. Okay, then we have to calculate what is the time. Okay, time here is equal to 1 over frequency. So 1 over 50. Okay, this one is the time. But we have 6 cycles. Okay, this one. Okay, 6 cycle with the short circuit capacity. So we have to time with 6 times here. Okay. Then we get the T is equal to 0.12 second. Okay, next we have to calculate what is the value of K. Okay. Okay, by using the equation, this one from the previous slide, I give. So we have to check what is the value of final temperature and also the initial temperature. Okay, so I put the table here, this one, for us to refer. Okay, so for these questions, refer to butyl rubber. So the final temperature is 220 and the initial temperature is 85. So put all the value in the formula, this one, and we can get what is the value of K, which is 88.6. Okay, then we have to calculate what is the A. Okay, this one is the area cross section of the cable. So by put all the value of this one is the I short circuit. Okay, this one is the K value and this one is the T. We can get what is the A, which is equal to 74.1 mm squared. Next, we have to select what is the standard cable size, which is we have to consider the nearest value from the calculated one. Okay, this is the calculated value. So we have to choose from the given in appendix A what is the nearest one. So the nearest is 95 mm squared. Okay, before we answer for questions number 2, we have to refer some table to get the value of K1, K2, K3 and K4. Okay, this table is from the previous lecture. Okay, lecture notes for part 2. Okay, you can refer them, but I will explain. For K1, okay, we can see here for this K1, we have to refer for ground temperature. Okay, this one. Okay, already mentioned in the questions, which is the ground temperature is 20 degree Celsius. So the factor of K1 is 1.12 in the circle. Okay, we have to choose this value. Okay, next we go to K2 table. Okay, for K2 we have to consider the number of cable in group, okay, and also the spacing. Okay, already mentioned in the questions, the number of cable is 2 and also the spacing is 45 centimeter. So we have to select 0.90 for K2. Okay, next we go to K3. Okay, for K3 we have to refer for a table for depth of laying, and also the cable size. Okay, we can see that the depth is 90 cm underground, already mentioned in the questions, and the cable size is between 25 to 300 square mm. Okay, this one is from the questions number 1. We already calculate the size is 95 mm squared. So So next we go to K4. Okay, this one K4. Okay, for K4 we have to refer to thermal resistivity soil. Okay, this one value and also the size. Okay, but for this cable, for this table, the maximum size is given 70. So we have to choose 70, the highest one. So the thermal resistive value is 200. Okay, and then we have to choose 0.90 for K4. Okay, by referring to the characteristics. Okay, after we know the value of K1, K2, K3 and K4, we can solve the problem for questions number 2. Okay, this is the answer for questions number 2. Okay, analyze again the size. Okay, so first we have to calculate what is the I load. Okay, this one is from the questions number 1 already calculated. Okay, the value is 126.36 M. Okay, S divided by square root 3 divided by 415. Okay, from the lecture note topic 2 or from the previous slide, I already explained how to find what is the value of K1, K2, K3 and K4, so that we can calculate what is the K value. So K is equal to K1 times with K2 times with K3 times with K4. So which is 0.8891. Okay, then from appendix A, that already given, the ampacity for 95 mm squared cable is 132 M. Okay, this one. So then we have to calculate what is the ICCCC, which is equal to K times with the ampacity. Okay, so the value is 117.36 M. Since ICCC below than I load, thus higher cable size need to be proposed, which is 120 mm with ampacity of 150 M. Okay, next we go to last question for practice 2. Okay, predict the voltage drop for both sides of cable found in Q21 and Q22. Assume average power factor is 0.85 and the cable length is 500 M. The tabulated voltage drop is defined as below. Okay, this is the formula for voltage drop. Okay, so for answering these questions, first we have to know what is the value of R and X for each cable from appendix B. Okay, so we have two types of cable. The first one is for 95 mm squared. Okay, the R is 0.67 and the X is 0.14. Okay, and for 120 mm, the R is 0.53 and the X is 0.135. Okay, this value we referred from the appendix B. Okay, then after we get the value, we have to use that value to calculate what is the voltage drop. So, voltage drop here, first we have to measure for 95 mm squared. Okay, we put all the value for R. This one is for R and this one is for X. Okay, this one is the power factor and this one is the sin theta. Okay, we have to find the theta first from the cos theta. So cos theta is equal to 0.85 and then you have to inverse cos 0.85, then you get the value of theta. Then you sin that theta to get the sin theta. Okay, this is the value for sin theta, 0.53. And then we have to times the value with the I load. Okay, this one. And then also times with the length of cable. Divide by 1000. So we get the voltage drop is 40.67 volt. Okay, next we repeat the calculation for 120 mm squared size. So the difference is for R, this one, and also for X. Okay, then we put all the value and we calculate the voltage drop is equal to 32.98 volt. Okay, so we can see here, if the size of cable is increased, so the voltage drop is decreased. Okay, so that is the conclusion that we can make from the calculation here. Okay, I think that's all for topic 2 example. Hope you can understand all the example. Is that? Thank you.